Constructing confidence intervals when the population standard deviation is known. Let's try another example. For a certain billing process, the number of days for customers to pay their bill from the date of invoice is approximately normally distributed with a mean of 47 days and a standard deviation of 11 days. And it's approximately normally distributed. A random sample of 10 bills from the billing process during the month of June results in the following data. Part A. Use the data to compute a point estimate for the population mean number of days from invoice to pay the bill. The point estimate for the mean will be the value of x bar. To find the value of x bar, I'm going to use my calculator. Okay, to find my average for this, I'm just going to add these up. 55 plus 45 plus 45 plus 42 plus 65 plus 58 plus 35 plus 36 plus 34 plus 60 equals divided by 10. My original data did not have any decimal places, so when I find my mean for my sample, I will round one more decimal place in the original data. So I'm going to keep the entire value here of 47.5. We're asked to construct a 95% confidence interval for the mean number of days it takes customers to pay their bills and interpret this interval. Alright, we're dealing with a sample size of 10. N equals 10. Now, a sample size of 10 would not be big enough except for the fact that we know we are dealing with an approximately normal distribution. So that suffices our requirements that we can use the normal distribution to construct our confidence intervals. Normal distribution. We've got a 95% level of confidence. The critical value, z sub alpha over 2, associated with the 95% level of confidence is 1.96. My formula, x bar minus the critical value, z sub alpha over 2, times sigma divided by the square root of n, is less than mu, is less than x bar plus z sub alpha over 2 times sigma divided by the square root of n. Substituting in the given values, I've got 47.5 minus 1.96 times sigma was given to be 11 divided by the square root of 10 is less than mu is less than 47.5 plus 1.96 times 11 divided by the square root of 10. We're going to punch this in our calculator now. 47.5 minus 1.96 times 11 divided by the square root of 10. And again, I'm going to round one decimal place for my lower boundary here. So I've got 40.7 days is less than mu is less than. Alright, second, enter. Let's go back up here and change the minus to a plus. Enter. 54.3. So 54.3 days. We were asked to interpret this, and we're going to interpret in the context of the problem. I'm going to use this part of the problem, mean number of days up through the bill. So we can be 95% confident that the mean number of days it takes customers to pay their bill is between 40.7 and 54.3 days. Remember, you always want to interpret in the context of the problem. It's very helpful to go back and use part of the problem itself, or the question rather, to come up with your statement. Alright, part C. Is there evidence that June payments were typical? June payments were typical because the mu of 47 falls within our range. Okay, so we can say for part C, June payments were typical because mu equals 47 days lies within the constructed confidence interval. Therefore, we do have evidence that this is